Hi everyone. So today I'm going to show you another problem taken from the Euler project problems. I'm gonna skip a few numbers because I don't want to show you over and over the same thing. So today's problem that we're going to look at is problem number 22. It's kind of a made-up problem. It's not something that you would encounter in real life, but yeah. Let's go for it. So the purpose of this exercise is taking a file which contains over 5,000 first names. The first thing we need to do is sort them by alphabetical order, and then working out in order, we need to compute what they call the alphabetical value of each name. That means replacing, summing up the position in the alphabet of each letter composing the word. They give as an example the first name Colin, and with C being the third letter, O being the 15th letter, and so on and so on. So its alphabetical value is 53. And if you retain the position in the list, Colin is the 938th name on the list. So if you want to get the score, you multiply 53 by 938 and you get 49,714. And what they propose is doing it for the whole file then. So it's a bit more interesting because we need to open files and work with files, but we also need to figure out how to do it quite efficiently. Well, I agree that 5,000 names is not a lot of names. On the other hand, if you need to make a lot of computations on each name, well, you could start feel like slowness appearing. So let's do this. So I downloaded the file, the test file in advance, and here you can see it's pretty massive. Okay. So first thing first, what should we get? So here we can already identify a few instructions and components that we need. The first instruction is, would you please sort in alphabetical order? So that means that ordering is important. Then we need a function that's able to compute for each name the alphabetical value of each name. And doing it for every name and then multiplying by the value in the list. Then we need also to store this data somewhere and then sum it up in the end. So probably the first thing we should do is writing a test. So test alpha value.py compute test compute alpha value. And they give us an example, name is Colin. So probably so we could say name is Colin. And then my function that would compute the alphabetical value would be called like this. Value of name equals 53. Okay, good. I could even just make it shorter. Okay. Sounds pretty simple. So here the problem is that we are testing two things at the same time. We are testing, one is the decomposition in individual numbers for each letter. And then we are also testing that everything gets summed up. Sum is pretty simple, so I think it's still relevant to just have one function that does it. We could have more debugging and more control over what we are doing if we were splitting it in two different functions. But here this summing is like very easy, so no need to focus on that. So pytest -v. Oh, good. So it picked up my test, so that's correct. Test alpha value.py. Then it tried to run test compute alpha value, and it failed because alpha value is not null. Great. So I just need to make a new file. Let's call it alpha value.py. And then for a given name, I don't know what to do yet. Oh, yeah, still not imported. From alpha value import alpha value. Fishy. It might happen that this namespace would be obscured by this variable. So this name, alpha value being the name of the function, is also the name of the module. Usually I would discourage that, because if I were to import the module individually and this function, we might be obscuring the name of the module and not being able to access either the module or the function. But yeah, here only one function, one module, no biggie. Okay, good. So the alpha value of Colin is none for the moment. Yes, of course. So now, how does it work? So we've got several ways of doing it. So first we need to decompose it in several components. You see, and then it would be return sum of decompose of name. So it doesn't feel like, actually I was a bit wrong earlier. It would really help if I would be able to decompose and have like some control over the decomposition. So here I would say that test decompose assert that decompose of always Colin equals, and then I can capture 3, 15, etc. Okay, actually it doesn't really matter the ordering. I used a list here. I could have used any other container that was unordered. But yeah, the list is fine. Okay, so we need to find, now we got the decompose function, so if I run my test again, it's going to fail twice, once saying that, yeah, decompose is not defined, and then that the sum of decomposition is not iterable. Of course, none. It's a non-value, so you can't really sum it, or you can't really iterate over it. So decompose should be decompose. Yes. Now at least this error should stop. So you see here I'm failing 2 tests at once. That's going to be a bit annoying. So we could use more flags from pytest. So we've got --lf for last failure, which is going only to run the latest failures. And we can also combine with -x that stops at the first one. So, okay, the first test is test decompose. But what if we wanted to focus on a different test? Because now test decompose comes before test compute alpha value, it's because it's the first one to be executed, since it's the first one coming in order. So what if we wanted to just run the other one? We could use so here we could use another flag, which is dash k, and then test compute alpha value. And so it would only run this one test. But for the moment, we are good with compute. Okay, so what does it say? Decompose, sorry. Okay, great. So we're going to focus on making one test passing at a time. So let's get back to writing this decompose function. So decompose is taking a name, which is a string, and then what should it do first? For letter in name, and then we should get the value of it. So letter value equals, and then what's letter value? So we could use, so usually in other languages, you've got two ways of doing it. You can use the OR function. So if you have two functions and one of them is OR, and it gives you the ASCII value on the ASCII table of a character. So if we want to take only letters in capital, we could just take the OR of the letter minus, if A is the first one, minus 64 then, and then we would get the correct value for the 26 letters of the alphabet. So that's one way of doing it. Another more pedantic way would be values equals, and then associating with each letter. You see where I'm going here. Or we could do a mix of both. So we could have, because computing the order and then because computing the order and taking out 64 each time is also a bit time consuming, so we could do it only once. So maybe something like a value is, actually this is really stupid. So instead of using the OR function, which gives for a given letter the number, we could use also the CHR function, and then compute a cache for values from 1 to 26. And so values would be a dictionary. And then you can have in Python 3.6, so or maybe 3.5 already, you can have like dictionary comprehensions. And so you can say, for example, you can have like keys and value for key and value in blah 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 blah. And since it's between the curly braces, it's going to be evaluated, and it's returning a pair separated by a colon. It's going to generate a dictionary like this. So we could try to use this syntax by saying, so the key here, my lookup key would be a letter. So it would be CHR of I, and then I itself. 64 plus I. So the letter number 1 would be CHR of 65, would be A. Clever. For I in range of 27. So it would go from 0 to 26, still not good, so 26, and then we need to add 1 to everything. Because if we go from 0 to 26, it's going to take, there's no letter 0, like A, the value of A is 1. This should give me a dictionary with the look that I would like to have. Sounds like it, yes. So it's the non-cumbersome way of generating this kind of mapping tables. You just need to figure out what's the pattern and what are the rules to generating it, and then usually with a clever one-liner you get it. Not to say that my one-liner is clever, but that's better than typing it 26 times. So for each letter in a name, the value of the letter is actually values of letter. And then we can have an accumulator. And then ACC append letter value. Sounds good. So for each letter in the name, there is some defensive programming we could put in place, because you see here I only wrote the range starting from 65 and there's 26 letters after position 65, meaning I get all the capital letters. What if a name contains lowercase? I'm not even talking about Unicode or whatever, or diacritics. I'm just saying what could happen, like what might happen. What might happen is, okay, one letter is in lowercase. So how could I be sure that I never hit this case? It doesn't cost a lot to just say, okay, so I take my name and I always uppercase it. Worst case, I'm always uppercasing something which is already uppercased. Well, okay, no problem, but at least if because you should always be careful with your inputs. You never know what's going to show up in your input, so it's a trade-off to make. But when the price of having a crash is higher than the price of spending a few CPU cycles uppercasing a name, it's not worth the effort of not doing it. So here I got my accumulator, and for each letter in my name in uppercase, I'm fetching the value of each letter, and then I put it in my accumulator, and then I should definitely return the accumulator itself. Okay, so PyTest has decomposed. Oh, great, fantastic, thank you very much. So it means also that probably since I got the first one right, I got also the second one right. Yes. Okay, that's good. Since this video is getting a bit longer than I originally expected, I propose you to stop now and resume later. See you next time.